All right, here's an example of evaluating a more complicated trig expression. So if you've been following along with these trig videos, then you might remember we've talked about a lot of properties and things like that so far. So we've talked about even odd properties, periodic properties, coterminal angles, reference angles, things like that. So we're going to use all of those to evaluate this more complicated trig expression here. Okay. So let's go ahead and get started then. So the first thing we want to do is, let's see, secant of negative 11 pi over 3 minus tangent of 11 pi over 3. Okay. So first of all, remember secant is an even function. So what does that mean? That means secant of negative theta equals secant of theta for every theta in the domain of secant. But we're not going to worry about domain yet. We haven't talked about domains for trig functions. That'll come later when we talk about the graphs. But anyway, so secant of negative theta is just secant of theta because secant is an even function. So we talked a lot about that in earlier videos. So in particular, specifically here, secant of negative 11 pi over 3 is just the same thing as secant of 11 pi over 3. Okay? So that's really great because now we can just forget about that minus sign. That's even functions are really nice like that. So okay, let's go ahead and work with that then. So secant of negative 11 pi over 3 minus tangent of 11 pi over 3. So let's write this down. Secant of negative 11 pi over 3 minus tangent of 11 pi over 3. Okay, so far we know that this equals just plain old secant of 11 pi over 3 minus, and then the tangent here part stays the same. Okay, so again, because secant is an even function, we can just do that. So let's erase this now. Okay, so that's nice. We got rid of that minus sign in there. What's next? Well, 11 pi over 3, that's kind of big, right? So if we go back to our unit circle, or if you aren't allowed to look at it, then maybe you just think about it. But pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Notice 11 pi over 3 is quite a bit bigger, right, than 5 pi over 3. So, but if you don't have the unit circle with you, maybe you have to do this on a quiz or a test, you aren't allowed to look at the unit circle. Just think, okay, well 11 pi over 3, is that larger than 2 pi? Let me check if it is. So let's see. We'll come off to the side here. So 2 pi multiplied by 3 over 3, what do I get? I get 6 pi over 3. Okay. So 2 pi is 6 pi over 3. Well, hey, let's zoom in. Hey, that is less than 11 pi over 3. Okay. So yeah, 11 pi over 3 really is larger than 2 pi. So, because remember, 11 pi over 3 is larger than 6 pi over 3, 6 pi over 3 is 2 pi. So 11 pi over 3 is larger than 2 pi. So let's go ahead and use coterminal angles, or in other words, periodic properties for secant. Okay, so remember, secant has period 2 pi, tangent has period pi. Okay, so we can think of it as periodic properties, kind of, sort of, but also remember, if you have coterminal angles, then they're going to have the same value trig functions, right? So in other words, secant of 11 pi over 3 is going to be the same value as secant at some other angle that's coterminal with 11 pi over 3. And what's coterminal mean? Remember, add or subtract 2 pi radians or 360 degrees as often as you want, and you'll keep getting coterminal angles. So remember, they have the same terminal side. So we talked a lot about that in earlier videos also. So anyway, let's find a coterminal angle, or find the coterminal angle, I should say, between 0 and 2 pi. Okay, so 11 pi over 3 minus 2 pi. Remember, 2 pi we just found out is 6 pi over 3. Okay, so let's do this. 11 pi over 3 minus 6 pi over 3, that's 5 pi over 3. Okay. So 5 pi over 3 and 11 pi over 3, they're coterminal. Since they're coterminal, they have the same secant, they have the same tangent. So then what we can say, to make this simpler, is, okay, well then this equals now, this equals secant of 5 pi over 3 minus tangent of 5 pi over 3. Okay. So we can think of that as using periodic properties because secant is 2 pi periodic. Secant has period 2 pi. So if we add or subtract 2 pi as often as we want to 11 pi over 3, where the secant stays the same. Same thing with the tangent, but the tangent has period pi. But we can add pi or subtract pi as often as we want, and we'll still get the same tangent. Okay, so here we subtracted pi twice, we could say. So we subtracted 2 pi, so we subtracted pi twice. Okay, so we can think of it like that. So you can talk about that in terms of periodic properties or coterminal angles. Same thing really, doesn't really matter. So anyway, again, 11 pi over 3 and 5 pi over 3, they're coterminal, so they have the same secant and they have the same tangent. So that's how we reduce this expression down to this guy now. Okay, so 5 pi over 3 is a little bit better, or it really is better than 11 pi over 3, because now 5 pi over 3 is a special angle on the unit circle. Okay? Now from here, what we could do is say, oh, okay, 5 pi over 3 is a special angle on the unit circle. I know what the cosine and sine are, so I can use secant is 1 over cosine, tangent is sine over cosine, so I could use those values that I know to evaluate that. And that's perfectly fine. Okay, if you don't know, you can go look at the unit circle. Okay, cosine of 5 pi over 3 is 1/2, sine of 5 pi over 3 is negative root 3 over 2, so you can use those to get the secant and the tangent. Okay, well, what if you don't remember that? And what if you're not allowed to look at the unit circles? So like what if this is a quiz or a test or something, and what if you don't remember these values? What if you only remember the values in the first quadrant, okay? Or what if these just escape you briefly? So what you could do is say, okay, there's more we could do here. Okay, so if we're not allowed to look at a unit circle, and if we don't remember those specific values, we could say, okay, well, hey, secant to 5 pi over 3, I could use reference angles on that. And yeah, reference angles are a little bit more complicated than just remembering these values here, but still, I just want to show you that there are various ways of doing this. And, you know, worst case, you won't have a unit circle to look at and you won't remember it. So we'll talk about what to do in that case. And also tangent, remember tangent is period pi, right? So for secant, we can add or subtract 2 pi as often as we want and the secant remains unchanged. Same is true for tangent, but actually, since tangent has period pi, we can just add or subtract pi as often as we want. So what we can say next is similar to what we just set up here. We could say, well, hey, 5 pi over 3, is that larger than pi? Well, pi multiplied by 3 over 3, that's 3 pi over 3, which is totally less than 5 pi over 3. So yeah, 5 pi over 3 is larger than pi, so let's subtract pi. 5 pi over 3 minus pi, remember pi is the same thing as 3 pi over 3. Okay, and then we get 2 pi over 3. So what are we doing? Why do we do that? Because tangent has period pi. So let's subtract pi from 5 pi over 3. We get 2 pi over 3, and the tangent remains unchanged. Okay, and 2 pi over 3 is maybe a nicer angle to work with. You might remember stuff about that, but even if you don't, there's still things we could do. And we'll talk about those too. So tangent of 2 pi over 3. Okay. Now, was this necessary? No, but again, I just want to point out there are many, many ways to approach this sort of thing here. Okay, now what we could do is say, okay, 5 pi over 3, 2 pi over 3. I don't remember values on the unit circle. I don't remember the trig values, or the x-coordinate, the y-coordinate. I don't remember those on the unit circle for these angles, okay? But I do remember for pi over 3 in the first quadrant, right? So how's that help us? Well, now let's think about reference angles, okay? So yeah, you might think, well, hey, isn't it getting a little complicated? Kind of, sort of, because if you do remember the values here, it'll make this simpler, but if you forget, again, I just want to point out that if you forget, you can use reference angles, and reference angles really aren't that bad. They just might seem bad because they do take a little bit longer to explain, but when you actually sit down and do them, they're really not that bad at all. Okay, so let's do reference angles on these guys here. We'll do it a little more quickly than we've done in the previous videos. Okay. So first of all, we've actually talked about this before. For stuff over 3, the reference angle is just pi over 3. Okay. So, but we also have to know what quadrant these are in. Okay, so we should know that at least. Even if we can't look at a unit circle, we definitely want to keep in mind, okay, 2 pi over 3 is in quadrant 2. 5 pi over 3 is in quadrant 4. Okay. So let's go ahead and work on a reference angle for 5 pi over 3. So for 5 pi over 3, and again, I know it might seem like more work than necessary, but I'm just pointing out various ways of doing these problems like this. So for 5 pi over 3, remember that's down here. Okay, so here's 5 pi over 3. So the reference angle is the acute angle between the terminal side and the x-axis. So that's this angle here. And what is that? Well, since we're in quadrant 4, the reference angle we've talked about a few times in earlier videos is going to be 2 pi minus 5 pi over 3. Okay. Well, 2 pi is the same thing as multiplied by 3 over 3. So that's 6 pi over 3 minus 5 pi over 3. That's just pi over 3. Okay. But again, you could just use the fact, if you're allowed to anyway, you could just use the fact that, hey, it's an angle something pi over 3, so the reference angle is pi over 3. Okay. So now, well, now let's say this also. Let's say secant is 1 over cosine of 5 pi over 3, right? Okay. And then, actually, you know what, let's not do it like that. Let's not do it like that. Sorry, we could do it like that. Let's not go that route. Let's keep it a little more simple than that. So sorry about that. Anyway. If you want to go that route, you can, but I don't want to do that, and here's why. So 5 pi over 3 is in quadrant 4, so let's write that down. 5 pi over 3 is in quadrant 4. 5 pi over 3 is in quadrant 4. So what could we say about the secant of 5 pi over 3? So the secant of 5 pi over 3, is it positive or is it negative? If you're in quadrant 4, remember quadrant 4 is to the right of the y-axis, so that corresponds to positive x-coordinates on the unit circle. So the cosine is positive. Since the cosine is positive and secant is 1 over the cosine, then secant is also positive. Okay, so in quadrant 4, secant is positive. Okay, so that's kind of where I was going with this. Secant, you can write that as 1 over cosine, and then you could apply this rule to cosine instead of secant, but I kind of changed my mind last minute and decided to do it like this instead. So either way is totally fine now. But anyway, secant of 5 pi over 3 is positive. So remember the rules for reference angles. That tells us then that secant of 5 pi over 3 equals secant of pi over 3. Okay? And remember, there might be a minus sign in front here, but because we've just found out that secant of 5 pi over 3 is positive, there is no minus sign in front here. Okay, no minus sign here. Okay? Now, how about for this other guy? So again, we talked about this in more detail in earlier videos when we talked more about reference angles. So anyway, that's it for that. Now let's do 2 pi over 3. So again, the reference angle for 2 pi over 3 is just pi over 3, so you might be allowed to use that fact. But anyway, let's talk about it from scratch, kind of. So x-axis, y-axis, let's draw 2 pi over 3. So 2 pi over 3 is up here. Okay, so here's 2 pi over 3. How do we get the reference angle for something in quadrant 2? Well, we take pi, subtract off this piece, and then we get our reference angle here. So pi minus 2 pi over 3. Okay, multiply pi by 3 over 3 for a common denominator. So this is 3 pi over 3 minus 2 pi over 3, which is pi over 3. Okay, so that's how we show that the reference angle is pi over 3. Okay. Now we look, since we're evaluating a trig function using reference angles, we're going to look at this and say, okay, what quadrant is 2 pi over 3 in? Well, 2 pi over 3 is in quadrant 2. Okay. So tangent, so we're talking about the tangent now. Tangent of 2 pi over 3, is it positive or is it negative there? Remember, tangent is only positive in quadrant 1 and quadrant 3, so in quadrant 2, tangent is negative. Okay, what if you don't remember that? Well, just remember in quadrant 2, the sine is positive and the cosine is negative, because you're above the x-axis where the y-coordinates are positive, so the sine of 2 pi over 3 is positive, and you're to the left, so you're above the x-axis, so the y-coordinates are positive, and you're to the left of the y-axis, so the x-coordinates are negative, which means the cosine is negative. So positive sine, negative cosine, so if you divide them, you have a positive number divided by a negative number. So positive sine divided by a negative cosine gives you a negative tangent. Okay? So in quadrant 2 and in quadrant 4, tangent is negative because the sine and cosine have opposite plus and minus signs. Okay? So anyway, since tangent of 2 pi over 3 is negative, then what we have here is minus tangent of pi over 3. Okay, but so ignore all this here. Okay, ignore that. But so tangent of 2 pi over 3 is the same as tangent of pi over 3, but we have to slap on a minus sign in front of it because tangent of 2 pi over 3 is negative. Okay, so in other words, tangent, remember that's how reference angles work. Tangent of an angle equals tangent of the reference angle, but you might have to put a minus sign in front of it, and in this case we do have to put a minus sign in front of it because tangent of our angle 2 pi over 3 is negative. Okay, because the angle 2 pi over 3 is in quadrant 2. Okay. So this minus sign comes from this minus sign right here. So these two minus signs are the same minus sign. And this minus sign comes from this one here. It comes from the fact that tangent of 2 pi over 3 is negative. Okay, so again, this minus sign is the same as this one. And this minus sign comes from this fact here. Okay. So continuing with this then, secant of pi over 3. Now you might not remember that, but remember that that's the same thing as 1 over cosine of pi over 3. And then minus negative means plus, so plus tangent of pi over 3. And again, you might not remember that right off the top of your head, but you definitely want to keep in mind that tangent is sine over cosine. Okay, so then what we have is, so cosine of pi over 3 is 1/2. So this is 1 divided by 1/2, and then plus sine of pi over 3 is root 3 over 2. So that's being divided by 1/2, also cosine of pi over 3. Okay. So then we simplify it. 1 over a half is 2. And then what happens here? Root 3 over 2. Let's erase this. Root 3 over 2 divided by a half. That's root 3 over 2 times 2 over 1, right? So dividing by a fraction multiplied by the reciprocal. So the 2's cancel and we just have root 3. So this is 2 plus the square root of 3. Okay. Okay, so a lot of work we did there, but I just want to point out that it's actually less than what it seems because we went through some details a little bit with everything that all the steps we did, we talked about the details and the reference angles, things like that. But again, I want to point out it would be made a lot simpler if we just remember, even at this step, okay, hey, 5 pi over 3, that's a special angle on the unit circle, so let me remember the cosine and sine. And if I remember the cosine and sine, I can get the secant and the tangent almost immediately. Okay, so, but if we don't remember that, the reason I went through all this extra stuff is to give you, just to show you that even if you don't remember what these special values are, you could keep using properties to reduce this to something simpler, okay? So maybe you only remember things about the first quadrant. Well, here's how you can use these properties to simplify something to get it to only be about the first quadrant, okay? So we started with secant of negative 11 pi over 3 minus tangent of 11 pi over 3, pretty goofy angles, right? The first we use even odd properties, so secant is even, so we could just drop that minus sign, totally forget about it. So that's what we did here. Then we used coterminal angles, or periodic properties, to say 11 pi over 3 minus 2 pi is 5 pi over 3. So coterminal angles have the same secant and the same tangent, and so on. So then we said, okay, well, hey, tangent of 5 pi over 3, that's the same as tangent of 2 pi over 3, because tangent has period pi. 5 pi over 3 minus pi is 2 pi over 3, so we have that there. Okay. Then we used reference angles to say, okay, secant of 5 pi over 3 is secant of pi over 3, because of how reference angles work. And likewise, tangent of 2 pi over 3 is negative tangent of pi over 3, because that's how reference angles work. Okay. So then this minus that, minus negative becomes plus, and then we just converted to cosines and sines. So really, if you want to evaluate trig functions of or trig expressions like this, then you could really just remember special angles in the first quadrant and then just keep in mind all the properties. Now, yeah, it does seem like a little more work, and maybe in some sense it is, but if it's harder for you to memorize all these values here, yes, the alternative would be to memorize all these values, and maybe that will be harder, but if you're allowed to use a unit circle, or if you can quickly reproduce it, maybe that's a little better way to go. But I just want to show you that if you can't do that, or if that's not an option for whatever reason, then you do have this other option here to go through this work with reference angles, things like that. So again, it's the point I really want to make here is with evaluating trig expressions, you have a lot of options, okay, a lot of properties to use, a lot of routes you can take. So anyway, that's example 1 here, evaluating more complicated trig expressions, and the answer here was 2 plus the square root of 3.